All right, hi everyone. We're looking at the last section of our similarity and proportions unit. All right, so today we're revisiting the idea of scale factor. We've talked about it briefly in one of our last units. So today we're going to revisit it in depth and make sure we're okay with that topic. All right, so just to remind everybody, scale factor is specifically a ratio used to enlarge or reduce similar figures. Okay. Now, specifically, I mentioned when we first looked at scale factor that it was the comparison of stuff from your new shape over stuff from your old shape. So when we look at that as a ratio, we get new over old. Now, more specifically, the new shape is called your image. Your old shape is called the pre-image. So just remember, pre means before. So in this case, before the change, before reducing or enlarging. Now, we also had other ways. We've seen other ways to write out your different ratios with your similarity statements. So a couple other ways that you can remember how these figures are created for these scale factors. You've got the old shape is similar to the new shape. And then in words, you also have old to new. So it just depends on the phrase of your sentence. How are things phrased there? How are they worded? And then there's also ways to tell from the pictures. Your new shapes will have apostrophes with them, or what we call primes. This is pronounced a prime. So if I have an A with an apostrophe, it's read as A prime. And we'll see some more of that here in just a little bit when we get into our actual figures. But we've got a little bit more vocabulary that we need to check out first. All right, so one of our first new words, when your scale factor is greater than 1, so that's what that symbol is for, it means greater than 1. That means that you have an enlargement. Which for your shape just means you got bigger. Now, when we look at your scale factors, scale factors are less than 1. That's what we call a reduction. Which means your shape got smaller. Now, sometimes when you're making scale factors, you might have a scale factor that is exactly 1, which is what we call an isometry, which really just means there is no change from one shape to the other. They are congruent. This is where you get your congruent figures, is from isometries. So just to kind of sum things up here, specifically a dilation is a transformation that again either enlarges or reduces. So our figures can change in size, but never in shape. A triangle will still look like the same kind of triangle. It's just either going to be bigger or smaller. Now, when we start using our scale factors and we start dilating shapes, we're going to be multiplying by the scale factor. And that's our clue here. Scale factors do a lot of multiplication. So let's look at our first example here and see how we can find the scale factor. All right, so example 1, find the scale factor and write it 3 different ways. All right, so let's look at your 2 shapes. Remember, first I need to figure out which one is the old, which one is the new. And so check out that small shape. Each of these letters all have apostrophes. That means that is the new shape. A prime, B prime, C prime, and D prime. Those are all your new shapes. Now, when I look at the old one, none of those 4 letters, A, B, C, D, in the bigger one, have any primes with them, apostrophes, which makes it the old one. So first thing I notice, I got smaller. So when I find this scale factor, it has got to be smaller than 1. So let's see what we have. All right, so we need to compare new stuff over old stuff. So let's start with our matching pieces on the top. So 36 over 42. We need to simplify this fraction down. 6 will go into both of these numbers, so they're both divisible by 6. So 6 goes into 36 6 times. 6 goes into 42 7 times. So 6 over 7 is possibly my scale factor. Now we need to compare the other set of sides, 14 and 12. If we don't get the same reduced fraction, then we do not have a scale factor. So let's see what we get for this one. So 14 and 12. 12 is from the new, so it needs to be on top. 2 goes into both of these, so 2 goes into 12 6 times. 2 goes into 14 7 times. All right, they are in fact the same, and that's what you want to happen. They must be the same. Otherwise, you do not have a scale factor, and these figures aren't similar at all. All right, so now that we've got our scale factor, we need to write it in 3 different ways, same way we did in our first section. So we've got the fraction way. I'm going to rewrite that a little bit better. 6 over 7, you've got with the word 2, and you have the colon. And that is my final answer. Now we can use these scale factors to find our missing pieces of information, especially when I only have one shape. So in example 2, we've got one triangle there. Given the figure below, find the perimeter of a similar figure if the scale factor is 3 to 2. So right away, 3 to 2 means I'm looking at 3 over 2. That's the easiest way to find out if your value is bigger or smaller than 1. 3 over 2 is the same as 1.5 bigger than 1. Our figure is going to get bigger. We can do 2 things. First thing we can do, remember scale factor is a multiplier. I can take each side and multiply by 3 over 2. And get the new measurement for each side of this triangle. So let's try that and see what we get. So 13 times 3 over 2 means it's 19 and a half. I've got 2 of those. And then my last one, 15 times 3 over 2, 22 and a half. So those are the lengths of my enlarged triangle sides. I can add those 3 up because again, we need perimeter. So my perimeter for this shape, once we apply the scale factor, 61.5. The other option you have, find the scale factor, find the perimeter of the original. So let's try it another way. We can take your original perimeter and multiply by the scale factor. So my original perimeter, when I add all 3 of these up, is 41. 13 plus 13 plus 15 is 41. multiply your scale factor to that. So 41 times 3 over 2, or times 1.5, the same 61.5. All right, so either way, we get the same answer. All right, so that is dealing with perimeter. Find your original perimeter, multiply by the scale factor. All right, now let's practice finding the scale factor when they give you the figures. All right, so right now we have two rectangles. I need to find the scale factor of these. So first I need to figure out which figure is the new one, which one is the old one. So check out the one on the inside. You've got all these little apostrophes here. So that means that little figure is the new one. So I need to get the measurements of that new figure. So we've got 6 going across. I'm actually going to write this on the bottom. I think I've got a little more space down there. And then it is 4 high. So when I get to make my scale factor, I want the 6 and the 4 on top because they're from the new shape. Let's do the same thing for the original one. All right, for my original one is 12 across and 8 tall. And again, I'm getting these numbers by just counting across the units, counting those squares. How many squares across, how many squares tall? So let's use this and make our scale factor. So again, we want new over old. Image over pre-image. All right, so we're going to use both sets of numbers that we found. So I've got 6 from the new over 12 from the old, which becomes 1/2 when it's simplified. Let's see if the same thing happens for the other direction. 4 from the new over 8 from the old for another 1/2. There's my scale factor. All right, so let's answer this question below. The scale factor was less than 1, so E prime, F prime, G prime, H prime is smaller than E, F, G, H. And again, that's because it was a reduction. If that scale factor was bigger than 1, you would have your enlargement. All right, let's try example 4. Determine if the dilation from A to B, so there's your clue, A to B. Remember, for A to B, I gave you the hint there, old to new, which means A is my old, B is the new. So I could really think about B as if it was A prime. Now I know exactly which shape is which. Any length from the new shape has to be on top. So let's find some pieces here. All right, any side that is flat, meaning easy to count, definitely go with those. I've got my vertical side here of my old one. I'm sorry, of my new one, not the old, of the new. That is 1, 2, 3, 4, 5 tall. And I'm going to put that over its matching side in A, which is only 4 tall. That does not reduce, so that possibly is my scale factor, 5 to 4. And again, that's all it takes is one set of matching sides to find that scale factor. There's our ratio. Now, if you were to use the smaller sides here, there's nothing wrong with that. But just be aware, because these smaller flat sides of these triangles, your original is technically 1 unit across, because it's going from a 1/2 square to a 1/2 square. So there's 1. While your new one goes 1.5. So for the shorter side, we would have 1.5 over 1, which gets a little bit, and it doesn't quite go 1. Look at where the green is. If the blue is sitting at the half, the green doesn't quite go to the half part. All right, so it's not actually 1.5 over 1, it's actually 1.25 over 1. So for those situations that get real difficult to see where they're hitting, then you don't have to use those sides, which is why I chose to use the other ones, the longer sides that are going up and down vertical, because they're a little bit easier to count. All right, so again, that is our scale factor. This scale factor is bigger than 1. Which means this is an enlargement. Okay, guys, I hope you enjoyed learning a little bit about scale factor and dilation. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.